Hello everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll carry out a titration. This is introductory or very elementary basic titration. Well, I shouldn't use the word basic, but very fundamental, very simple kind of titration between HCl, which is hydrochloric acid, as well as sodium hydroxide, which is NaOH. So without worrying too much about the balancing equation and stuff, because they will come in the main theory of the topic on stoichiometry as well as acid-base reaction, I will just focus more on the practical aspect of it. So we've got this thing which is called a pipette. So this is P-I-P-E-T-T-E. This is 25 ml or 25 cm cube pipette. It has got a mark that measures up to this mark. There will be 25 ml or 25 cm cube. First of all, we are not sure if we have been given a clean pipette or not, so we should wash the pipette. I'm going to put distilled water through it. So distilled water or deionized water. I don't have a sink near me exactly. I don't want to be moving the camera around. So what I'll do is I'll just wash it into a beaker. So when you're washing a pipette, you want to make sure that you got a bit of water in the bulb. So I don't have that much water in the bulb at the moment, but you want to be washing it so that you roll a bit of the distilled water inside, such that it becomes dry. Okay, but very importantly, because you got water inside here, and later on you'll be filling in with your chemicals, with one of these P or Q. So you want to make sure that you will take in a little bit of the substance. You're going to fill it in and wash it with that, or basically rinse the pipette with the substance that you're going to fill it in as well. All right. I'm missing a pipette filler, but I'll go and get it in a little bit. This is a burette, B-U-R-E-T-T-E. A burette measures up to 50 ml or 50 cm cube. So it reads from 0, and then it reads 1, 2, 3. So you read downward. Be very careful about reading burette. At least in O level or in IGCSE level chemistry, your burette reading will be to 1 decimal place. So make sure you can read it to 1 decimal place. And whatever you do when you start from 0, it should be read and recorded as 0.0 cm cube. Okay, so just like what we did with the burette, with the pipette, I will rinse this one with a bit of distilled water. But mind you, when we rinse something, I had the tap closed, so the bottom bit hasn't been rinsed with distilled water. So this is now distilled water. I'll just roll it sideways so that I'm rinsing the top and the bottom bit, and I'm rinsing all around the burette. So I'm slowly. I don't fill it up to the very top. I just fill it with a little bit of distilled water, and then roll it around slightly like that. And I do not forget that I haven't opened this thing at the bottom, so the distilled water hasn't passed through and washed the bottom yet. So what I'll do is I'll open the thing into my wash beaker here. Usually you'll be working next to a sink, so you'll be alright. So I already opened it to wash this thing away. So this is already distilled water inside. I can just throw it out from the very top. But when did I throw out all the washings, the stuff that I wash it with, from the very top of the burette, pour it into the sink. I still have that water which I haven't released, so this is the dirty washing. I should open up the tap. Make sure you open up the tap, and then they will get rid of whatever you have inside there. So now I already opened the tap, all the washing already come off. But just like with the pipette, whatever thing that go into the burette, I have to rinse the burette with the thing that I am supposed to put it in there. Okay. So I've got two chemicals. I've got chemical P, which is hydrochloric acid. So P is HCl. The instruction actually told me to put P, which is HCl, in the burette. And I've got Q, which is NaOH or sodium hydroxide, the alkali. They asked me to use a pipette to take out 25 ml of it. I'll go very quickly and grab myself a pipette filler. So this is called a pipette filler because you use it to fill up a pipette. There's a button there. I'm not too sure how clear it is. Probably not too clear because, well, it's in black. There's a letter there that says S. That means it will suck in the solvent, or basically whatever solution. Sorry, not solvent. The solution that you are sucking out. E stands for eject, and A stands for you allow the A to go in. So you will press A, and then you will squeeze this, and then you let go of air, and this will be inflated like this, and then you put this into your pipette. Okay, so remember we have to rinse our pipette with the solvent that we are putting it in. This is glass, this is rubber. You want it to be snug, meaning to say it's a little bit tight, but you do not want to be pushing it all the way because glass, if it goes through the rubber, mind you, it's going to be dangerous for you. Okay. I'm still doing the washing stage because just now I washed with water. There's a little bit of water in here. Little bit of water in here would mean that it will affect the concentration of the Q in your titration. That's why we have to wash it. We have to rinse it with the Q, which we are supposed to fill it in. So I'll just take in a little bit. So this is not for our exact titration, not even for our rough titration. As you can see, I could let go of it and it doesn't really come off, because it still has got a pipette filler on top. What I'll do now is I will let go into the sink, which I don't have next to me, but I have a wash bottle. So I will tilt it now. Oops! I will tilt it now a little bit sideways. You can see that there is a little bit of Q in there. I want to wash the bulb of the pipette. I want to wash the bulb. This is called the bulb of the pipette using the solvent. So I'm just rolling it out, and then I will roll it out into the sink, or I will roll it out into this wash beaker, which is close to me. Okay, so now I'll just leave it to dry there. Oops, maybe the other way around. Okay, now that was done with the pipette. Now I'm okay with the burette. P goes in the burette, so P, well, not all the time, but my instructions specifically told me that P is my hydrochloric acid that will have to go in the burette. So if I put this in the burette, again, I'm not filling it up to the very top. Instead, what I'm doing instead is just fill it up with a little bit of P, because I'm going to wash this. In fact, I'm going to rinse this burette with the P as well, because whatever distilled water you got in there, that will affect the concentration of P, and therefore it will affect your final titration volume of whatever is required of P to neutralize or to react with the other solvent. So I'm going to roll it around so that the P will touch each and every side of the surface. But I also remember that just now, just like with the distilled water, I need to open the tap in order to wash the bottom with the solution P, which I'm going to fill this burette in. So I'm just going to let go of it, and the P will flow through from the top, from the bottom, sorry. And then I just let go of everything, and don't forget to let go of the little bit of P which is stuck at the bottom there. So now I am okay to start my titration. I will first fill in my burette. So P, according to the instruction, HCl goes in the burette. So I just fill it up. Doesn't matter. So I overshoot a little bit beyond the 0 mark there. But what I'm going to do is, remember that just now we already closed the tab. So this one hasn't been filling in that much space there. Before you do your rough titration, make sure you open a little bit of this so that you let go of, you have a little bit of P passes through the bottom and fill up the space there. Okay, so this one is way over the 0.0 cm³ mark, but it's alright. So this one is better if you actually do it. Okay, so what I'll do is I'll try and get it to 0.0 cm³ mark. I have a wash beaker here. This is dirty stuff, all the washing, because I'm not near a sink. In the real thing, what you do is you do not ever put the P, the one in the burette, back into the bottle, because this is accurate stuff. You don't want it to be contaminated by the stuff from your burette. Yes, you already clean it, but you just don't know whether it might be contaminated or not. So always keep your solution in the bottle that you're given, cleaned. Okay, so just throw out whatever that passes through into a wash beaker or into the sink. Okay, let me just get this right. So that's 0.0 cm cube. So you read from below the meniscus. I hope you can see. I need a white surface. I think this one will do. Okay, so how you can see that there is 0.0 cm cube. So on a white surface, this is a white tile, it's much better. You record this as 0.0 cm cube. At least in the O level or IGCSE level setting, you record volume to 1 decimal place. Okay, what I have now is a conical flush. This is called conical flush. I already pre-washed it with distilled water before, so it's a bit dry now, but it's alright. So I know it was clean because I washed it previously. Remember your pipette filler again. So when I press A, it's going to go fully rounded again. Press A and then push it in. Then you're gonna, I don't know, I call it inflate, deflate, inflate, I think. So it's gonna have A inside there. So you're gonna push in the pipette filler very gently, rotate it around until you get a snug fit into your pipette. So what I have now is S. I already washed this pipette with the solution that I'm gonna fill it in. There was Q. Then you just put it in, and then you just press S. As you could see, the solution is slowly going up. Okay, it's always a personal thing, but I always believe that it goes a bit faster if I tilt it sideways. But I don't know. I mean, it's just the way it is. But yeah, I mean, we always take a little bit extra. As you can see, we take a little bit extra. So there was the line there. Avoid dropping the extra thing into the same bottle because you do not want to contaminate it. So what you do is, so this is overshoot the line. So this is not 25 ml. You want to get it 25 ml. So pour that into the sink by pressing E. Okay. So that's 25. Yeah, that's give or take 25. Let me put a white towel on it. So you're reading below the meniscus, so I hope that you can see it's 25. Maybe it's just below. Now that's alright, that's just 25 ml there. So there's Q. So that goes into the conical flush. So you see, conical flush, and then I'll press the button E there. And when I press the button E, it will start ejecting. Okay, so what you do is you don't press it and let it go like that. While pressing E, don't let go of that button E there. Rotate around the top bit so that you can get this pipette filler off. And then gravity will do its job. Just let gravity do its job. Do not tap, do not do anything. Just let gravity does its job. Okay, then it's closer towards the end now. So closer towards the end, and you are getting to drop wise. When you got to the end, this is what I was normally taught. Okay, careful with glass, tapping on glass, but you tap very gently. 1, 2, 3, 4, 5. So I've got a little bit of Q left in there, but that is already taken into account in the level accuracy. As you could see, there's 25 ml. 25 ml plus minus 0.06. It's already taken into account the level accuracy that's at the end there. Just as long as you tap the little bit that was left in there, you can't get rid of the very, very last drop in there. It's just the design of the apparatus. They already take into account the experimental error there. Now, this is Q and NaOH. This is burette filled with P, which is the HCl. So we'll do neutralization. But this is colorless, and this is colorless. This has got H plus ions because it's acid. This has got OH minus ions because it's alkaline, it's basic. We can't see colorless, we can't see the H plus, we can't see the OH minus. That's why we need an indicator. This is called methyl orange indicator. So the indicator doesn't go into the burette, it goes into the solution that's pipette out. So this was NaOH, this is alkaline. So this is methyl orange, which is orange. I add in a couple of drops. I mean, the amount of indicator shouldn't affect your titration at all, but you should be consistent. You should be consistent with the amount of drops you use, just so you get the enough color intensity. I've added like 2 drops so far. Perhaps I just add 2 more drops. So altogether I have like 4 drops. 3 to 4 drops in general is alright. Some people might argue, methyl orange is a solution. Methyl orange is a solution. It contains water. So we have added a little bit of methyl orange here. We have added a little bit of water in here. Will that affect our titration volume? It's a very good question, because you have added a bit of water to 25 ml or 25 cm³ of Q, which you pipette out. So the amount of Q that you pipette out hasn't changed. You are just adding a bit of water to it, but the total amount of Q is still the same. So if your mole of Q is the same, that means your mole of the P, the reactor with Q, shouldn't change at all. So it doesn't matter how many drops of the indicator you use. Yes, you'll be changing the concentration of the Q in here because you're adding a bit more water to it, but it will not affect the amount, which is the mole of the NaOH, which is the mole of the Q that's already present in here. Methyl orange is this color. It's yellow not too sure how well the color will appear on the screen, but it's yellow against the white tile. It's yellow in alkali. Okay, so I'll just do a rough titration. So if I just grab like this one, because I'll probably be doing a screen, well, basically picture-in-picture comparison. So this is how you set up your titration table. Usually you're given the table, but what you would do is, before any experiment, don't just be thinking about doing, plan your experiment ahead as a chemist, as a scientist, okay? Titration number 1, 2, and 3, something like that, in case I don't get to, do the picture-in-picture. So what we will do, oops, I don't want that. So what we will do is we are going to record the volume. So we have initial volume. Initial volume means the volume in the burette at the very beginning, and we'll write down the units like this. Okay, so we write down the units so we don't have to write down the units in our entry. And then I will have final volume that I will read from my burette. And then I will have volume of, I use P in the burette, so volume of P used. And I will have best titer, which I'll indicate with a tick. Alright, so this is basically a table which I can come up on my own. But what happened then is, you're usually given this table. Does not mean that you don't need to know how to set it up yourself. Okay, so what do we have? We started with the burette at 0.0, so our initial volume is 0.0 cm³. So I could write my initial volume on the top, or I could simply move them around and swap it around with final volume. Because does it matter where I put it? It shouldn't, because it depends on the label. Label is what you put it, or sometimes labels is what the question gives you. So follow the label. Initial volume is what you started with. You read burette from up to down, 0.0 cm³ there. Okay, so I'm going to do my rough titration now. So in my rough titration, oops, that thing doesn't hold very well. Just give me a minute. I think I'll swap the burette and the pipette thing around because I don't want my burette to... Actually, I think that's alright. Okay, I think it's alright. I just need to make it a little bit tight. Okay, so we are ready. I'll put a white tile at the bottom. When we're doing our first titration, do not try and do it drop by drop because you'll be wasting a lot of time. Instead, try and do a rough titration, being very fast. Just let the thing here move at full speed. Okay, so let me just get this right, and then you can see what's going on. Okay, so I want to control this so that this is at full speed. I am right-handed, so I'll be swirling this. I call it swirling. Okay, I'll be swirling this on my right, and I'll be doing the knob on the burette with my left hand. Okay, so I'm just putting this on full speed, continuously swirling. I want to see, this is rough titration. I don't really care about drop by drop yet, because if I don't know where I'm fishing, if I don't know where the endpoint is, how in the world am I supposed to do the exact titration, being exact drop by drop later on? So the color change, it should go from yellow, being an alkaline, and then as you can see, it's already gone a bit. No, it's still yellow, so it is still yellow. Hopefully you can see. But when I added a little bit of it, you could probably see that it goes orangey a little bit. There you go. You kind of go orangey, and now it's kind of pinkish. Okay, so this is already exceeded the endpoint. It's just the indicator. Well, the solution is not very concentrated. The indicator wasn't added in a huge amount, but this is probably in excess already. So just take note of the color, and I'll take note of the volume anyway. So it's around 25 point. So this is not exact, yeah, this is rough. So I stopped as soon as I saw the color change, but it wasn't done drop by drop. So you read this as 25 and this is 26. So you do not read upward, you read downward. Okay, follow the reading 25, 26, 27. So you read downward. So if I hold it, in fact you should read it while it's being mounted on a retort stand. Not too sure how well this one will read. Perhaps I'll move up the camera a little bit so that it's on a horizontal level, because you know you don't want to be reading parallax with a parallax error. So give or take is around 25 point something. So make sure you have it to 1 decimal place. If I put this back on the stand and then I'll read it, 25.6 cm cube. So what we do is we go back to our table here. So we write 25.6, and then you put in your calculator 25.6 minus 0.0, final volume minus initial volume. Then you can get volume of P used being 25.6. Remember, this is rough. We always try and do the first one as a rough titration. As I said, if you don't know where you are fishing, how would you know where you're going to stop later on? Now, one student actually make this mistake, and I think it's worthy to mention it. So now you got around 25, 26. If you got another 25 point something, so this one goes up to 50 only. So 25 point something plus 26 cm cube is going to give you 51, which you don't have 51. So before you start your second titration or any follow-up titration, make sure you top up depending on how much volume you reckon that you will need. So do not make the mistake of letting it run all the way past 50, then you're like, oops, no way. Okay, then you have to restart all over again. So be very careful on that. So I'll just top up my burette. That is with solution P. But before I top up my burette, I just want to show you what happened when I add a little bit more. So this is the color just for the rough titration. Now I'm just going to add a bit more because we are still doing rough titration, right? We don't care about it. I'm just adding a bit more, and the color hasn't changed. It's kind of like this pinkish, pink reddish. So it's supposed to be reddish because of the concentration of the solution. I think it's not very concentrated, or perhaps with the lighting. I can add a bit more indicator and show you what color it should be. Yeah, this looks a bit better. So when I add a bit more indicator, the color is a bit more orangey. Sorry, not orange. Orange is at the end point. This is more reddish, which is what happens when you have a lot of excess acid. Okay, so it doesn't change anymore. Okay, so what we'll do now is I'll try and do my exact titration. Before I do that, I want to fill up my burette with P. So I don't have to start from 0.0. My point is I don't have to start from 0.0. I've just filled it up to around 8 point something. To make my life easy, I'll probably get it down to 10 so that it'll be easier for me to do my addition. Okay, so this is 10.0 cm cube. So again, it's not horizontal level because I don't want to be tilting the camera that much. Perhaps I should. Okay, so that, trust me, is read as 10.0. Okay, now just let that sit still, and then I'll pipette out Q. So same thing, fill the pipette filler, put in the pipette, oops, put the filler into the pipette, and then I will suck out from the bottle, Q, 25.0 ml of Q. I usually do it at a bit of an angle just because I don't know, I'm not superstitious, I'm just, it's just something that I've always done and I thought it would be faster, but I don't think it makes too much of a difference. We are going against gravity after all. So the sucking bit is the bit that is quite slow. Once you get past the bulb, it's actually pretty quick. So again, I've sucked out a little bit extra. I try my best not to put it back into the bottle because it's actually bad. Sorry, it's actually a bad habit to put stuff back into the bottle because you never know how you're going to contaminate the thing, okay? I'm just going to lift this up a little bit so they can see it, okay? So hopefully you can trust me that, you know, it is at 25.0 mil or 25.0 cm cube there, okay? So, don't worry about the fire driller, just testing the fire driller. Okay, so that's 25.0 mil. And I will put that into my empty Conical Flush. So you can't get exact titration results with just one exact titration. You have to have at least 2 exact titrations in order to, you know, decide which one is the best titer. So I'm just letting it go now under gravity. So I already took off the pipette filler. Just let gravity does its job and it should be alright. So it's just going down now, it's fine. Remember to tap the glassware very, very gently because you don't want to break pipette or the Conical Flush. Okay, so tap 1, 2, 3, 4, 5. Okay, that should be alright. And I need to start recording my volume. I started my, oops, okay, so I'll lift this out a little bit. I started my burette reading there with 10.0 cm cube. So 10.0 cm cube, just like that. Okay, and I know my rough titer was like 25.6, so that means around 25.6 plus 10.0 cm cube, there will be just a little bit excess. So 25.6 plus 10 is 35.6, which means I can let this run until very close to 35.6. Then I need to slow down and do drop by drop. Otherwise, I'll just be wasting time by adding drop by drop from the very beginning. Now we know where we are fishing. We need to add around 25.6 cm cube to 10.0 cm cube. That is around 35.6. Do not be greedy. Instead, before you reach 35.6, so I did not exceed by a lot just now, so I would say minus 3 cm cube, so 35.6, which I got by, you know, adding 10.0 with 25.6, they'll give me 35.6. I take away around 3 cm cube, so I can slow down around 32.6, give or take. So I remember to add my indicator. No indicator means, well, you won't see any color change. So as I said, the amount of indicator shouldn't matter, but you want to be consistent with how many drops you use. Because consistency means you're doing the same thing throughout your experiment. Okay, the drop is not doing its job that well. I might just have to, well, use my best estimate to say this is a couple of drops, but this is in alkaline solution, so that's why it's yellowy. Okay. So now I will just let this run because it runs from 10.0 cm cube plus 25.6. 35.6 is around here. 35.6 is around, okay, I can't show it that way, but it's somewhere around there. But I will slow down. I will slow down when it get close to, 32.6. Okay, so as you can see, it is still yellowy. And the reading now is 32.6. I started from 10.6, yeah? Okay, sorry, 10.00, 10.0 cm cube, sorry. 1 decimal place for O level or IGCSE level practical. So I do not do drop by drop from the very beginning because it will be a waste of time, and I don't have that much time after all, right, in the exam. So I don't care about the reading now. I no longer look on the burette. Instead, my eye focus on the color in the conical flask. So I hope if I just zoom this in a little bit, so you know you are focusing on that. Okay. So get your burette controlled very well. So get it done right first before you swirl or anything. So that's why we don't do this at the very end. We do it few cm cube before the end. So that is drop by drop. I already managed to get it drop by drop. Hopefully you can see the drop by drop. I know it's still a long way to go to the end point, but you know, I try not to be greedy. I just focus on the color change there. Okay, so I don't want to be looking at the camera because I might miss it. So I just keep on swirling it. My hand control on the burette tab, on the tab of the burette. When it one drop color change from yellow to orangey, then I will stop. Okay. So quite close to the end point already. You don't want to be greedy, otherwise you will end up doing the exact same thing all over again, and you don't have that much time to spare. Okay. Not yet. I think I stopped too soon. So it is still yellow, as you can see, yeah. Okay, not too sure how well the color will, not too sure how well the color will represent itself, but you know, yeah. Okay, so let me get it drop by drop again. So by right, if you are not performing for the camera, you shouldn't stop the drop by drop. You just keep on going. I think this is the end point. Okay, so this is kind of like orangey yellow now. Just now was more yellow. Now it's more orangey yellow. Okay, I'll lift this up a little bit, and that way it will look a bit better. Okay, so orangey yellow, and my reading on my burette is 35.2. 35.2. Okay, you read from the top, 35.2. Okay, not too sure if I hold it horizontally or not. 35.2, one decimal place, yeah. 35.2 is my final volume, but remember, I started from 10.0, so that's why you have to record before you started, rather than waiting until the very end. So pop that into your calculator, and I get 25.2. At the moment, I got 25.6 and 25.2, but remember 25.6 is a rough titration, so you cannot really use that and say that that is your exact titration. No, okay? So we need to do at least one more titration to try and get it right. If you think this is not the end point, why not we drop one more drop and see what happened, okay? So take note of the color first. Okay, and I'll add one more drop or two more drop and see if there's any further color change. As you can see, it doesn't really go any further, which means it's no longer yellow, it's already turned orange. Okay, I can add a lot more, and the color has pretty much remained the same. Alright, so that's how we know it's over. What I'm going to do is I'm going to reuse the conical flask. I'll just throw this down the sink. I have washed this with tap water once. I'll just rinse it with distilled water. It shouldn't matter that much, but I just want to be sure. So I rinse it with distilled water. Does it matter if it is wet? So it's got a bit of water inside. It shouldn't matter, just as what I said earlier, because when you got a little bit of water left in there, you're going to put the pipette out. You're going to pipette out 25.0 cm3 of Q into here. So as long as you have 25.0 cm3 of Q into here, the mole of Q in here doesn't change. Therefore, that shouldn't change the volume of your P that's in the burette to neutralize the Q. So a little bit of water left in there will not affect your titration volume, because you will still be pipetting out using the pipette to get 25 ml or 25 cm3 of Q into here. Alright, so that's why it doesn't matter. So it's a popular question actually in alternative to practical, and even in a theory paper, even in A level as well, because a lot of students, they know how to do titration, but they never really think about why, why is this possible? Why is this one not possible? So I'll try and get my exact titration done for this second one, because you can do as many times as you want until you get consistent results. But minimum is you must have at least 2 exact titration. So what do I need to do? So there's 25.0 cm cube. So just let gravity does its job. I already taken off the pipette filler. Please make sure you don't drop anything outside the conical flush, because if you do lose any single drop outside the conical flush, that means not all the 25.0 cm cube of Q goes into the conical flush. Then you will affect the volume of the P that's required to neutralize this thing. Okay, it's already been about half an hour, so let me just finish this and get this over with. All right, 1, 2, 3, 4, 5. That should get rid of the last drop in the pipette there. Okay, don't forget, we should top up our burette with P. I do not have to start from the very top, so I do not have to start from 10. So I could even start from 20, because 20 plus around 25.2 is not going to overshoot past 50. Okay, so I want to get rid of a little bit of these. So I start from 20.0. So I should probably move this up a little bit. So I'm holding it with my hand, so it's not that stable as compared on the retro stand, but it's going to be 20.0. So I will start from 20.0. So again, as with any experiments, do not wait until the end to fill in your table. You record results as you go along. Okay, so your rough title was 25.6. Your exact just now was 25.2. So 25.2 plus 20.0 is going to give you roughly around 45.2. But that's exact. 45.2 is going to be quite exact. So I want to go up to 44, and then I will slow down. Okay, so I don't want to be too greedy, but yet I don't want to waste too much time, because time is something that you don't really have in the actual thing. So, but do 2 or 3 as you are practicing to get the hang of the skill. Yeah, this is methyl orange in alkaline solution, which was Q, and I start from 20. So I should get 25.2, which is around 45.2, but I will slow down when it gets to 44, because I know I already done my exact titration once. But just one exact titration is not going to be enough. So make sure you don't drop anything, so you can move your burette a bit downward, so that you're not losing anything at all. So I just want it to go up to around 44, then I'll do it drop by drop, because I started from 20. Remember, I started from 20. Okay, so it's now 44, but it's not the end point yet. It's now 44, it's not the end point yet. I make sure that as I'm showing this video, I don't actually like to move my stuff around, because you never know what's going to happen when you move your stuff around. Okay, so yeah, so I could swirl this, and you could see it's still yellowy because it hasn't passed the end point yet. I know it because I've done my exact titration just now. Okay, now I will set it to go drop by drop. So don't swirl it yet, get it drop by drop first. Takes a bit of finesse control. Okay, you need a little bit of good control. Okay, so it's drop by drop now. I swirl. My eyes are just on the conical flush, not on the volume. Never on the volume as you're doing exact titration, because now you're just focusing on the color change. Do not even look on the burette volume. Do not. Okay, make sure your eye is totally focused on just the color change and on the tab, the other hand on the tab. When it changes color, then stop. Okay, so I know it's slow, but you know, it's required. It is actually painfully slow. Let me check. There's 45.1, perhaps one more drop. If we think this is endpoint, do we think this is endpoint? This is a bit yellowy orange now. Perhaps we are near that point now. In fact, the reading is actually 45.10. So I'll probably add one more drop. So now it's 45.10. I'll add one more drop and see if there's any color change. So 45.1, okay, just very carefully, one drop. And I think it stopped there. So there's our perfect orange there. So it goes from yellow to orange at the end point, from alkaline to this neutralization point. And my burette reading is, well, unsurprisingly, 45.2. So if I lift this up a little bit, so I have 45.2. Okay, so you read from top to bottom because top bit is 45, bottom bit is 46. So there's 45.2. I could try and add one more drop. I already said it's 45.2, yeah? So I just add one more drop and see what happens. So the color is slowly turning more and more orangey, but the moment the color changes, so that's when I know I roughly got the end already. Okay, so it's now 45.3, but the more I add, the color doesn't change anymore. It just remains this. It looks kind of orangey actually. Of course, the more acid I add, then it's gonna go more pinkish. All right. So 45.2 is my final volume just now. I take note of it instead of just letting it go further and further. So 45.2 is my final volume. Okay, but use your calculator, take the difference, then I get 25.2. You will notice that the first one is a rough title, but 25.2 and 25.2, I've gotten two readings. Sorry, let me just move that a little bit further. So the whole idea of doing exact titration is so that I'll get two readings. Now I have 25.2 and 25.2. I can put a tick on both of them because they are fairly accurate, number one, and they are within plus minus 0.2 cm3. So this is called concordance. Concordance means consistency. Your best title that you put a tick on has to be within plus minus 0.2 cm3. You want it to be as close as possible because you're the one doing the titration, as exact as possible. So don't try and do them so many times and get different values because you know what you're doing. Okay? So that's all really. So thank you for watching, and yeah, subscribe to the channel and click the button on the bottom right to do that. And follow me on ptet, well, on Instagram, Facebook, and Twitter at ptet.chemistry. Thank you for watching. See you in the next tutorial video.